Functions of several variables. A function may depend on more than one variable. An example of such a function is y equals f of x1 and x2, where x is an element of capital X sub 1 and x sub 2 is an element of capital X sub 2. Then the domain of the function is written as capital X equals capital X sub 1 times capital X sub 2, where the symbol times the multiplication symbol when applied to sets means to take all possible combinations of elements of the two sets. For example, the set capital X equals open bracket 0, 1 close bracket times open bracket 0, 1 close bracket contains all the pairs of real numbers between 0 and 1 inclusive. The function f associates elements of the domain. The set capital X equals capital X sub 1 times capital X sub 2 with elements of the range. The set capital Y, that is, f is a mapping from capital X to capital Y, which may be denoted either by f colon capital X yields capital Y or by f colon capital X sub 1 times capital X sub 2 yields capital Y. An example of mapping from a pair of variables to a single variable is the well-known measure of physical fitness, the body mass index, open parentheses, capital B, capital M, capital I, close parentheses, which is a function of weight in kilograms and height in meters. Capital B, capital M, capital I equals weight over open parentheses, height, close parentheses, squared. If we let the variable z measure the BMI, W reflects the weight, and H denote the height, we can write this function more compactly as z equals f of W and H, which equals W over H squared. Other examples of functions of two or more variables are called and here there are 3 bullet points. The first bullet point, Cobb-Douglas function with 2 variables, y equals f of capital A and capital L, which equals 3 times capital L to the power 0.33, and we multiply that by capital K to the power 0.66. Second bullet point, Cobb-Douglas function with 2 variables and 2 parameters, y equals f of capital K and capital L, which equals capital A times capital L to the power alpha, that's multiplied by capital K to the power 1 minus alpha, where capital A and alpha are parameters rather than variables. They represent unknown numbers rather than quantities that can change. The previous example is the special case where capital A is equal to 3 and alpha equals 1/3. The third bullet point, Cobb-Douglas function with n variables, y equals f of x sub 1, x sub 2, x sub 3 through x sub n, which equals capital A multiplied by x sub 1 to the power alpha sub 1 multiplied by x sub 2 to the power a sub 2 ellipsis, which indicates all the way to x sub n to the power alpha sub n.